Alright, Section B, May 2015, IBSL Maths, Paper 2, Time Zone 1. Following diagram shows a straight shoreline with a supply store at S, right there, a town at T, and an island L. Boat delivers supplies to the island. Fair enough. The boat leaves S and sails to the island. Its path makes an angle of 20 degrees with the shoreline. It says an angle of 20. Well, I'll assume it's degrees, and maybe it just didn't print on this version. The boat sails at 6 kilometres per hour and arrives at L after 1.5 hours. Find the distance. Well, this one's going to be pretty easy. Now, I know it says to show you working on a separate page, but you're used to this by now. We just have to do it where we can. So, distance is going to equal your speed times your time. Right, something like that. Therefore, the distance equals 6 multiplied by 1.5. The distance equals 9 kilometres. And yes, you could use your calculator because it is a calculator exam, but I'm sure you can cope with that one. Now, the position of the supply store is going to move so that its distance from L is only 5 kilometres. So we've got two options there, P or Q. Find the size of SPL and SQL. So we've got a distance now, which is helpful. So we might label that in. Once I can, we've figured out if I turn this upside down, I get a better view of the. Don't know if that really helps, but we've got this distance here. There's 9 kilometres. That's 20, and I'm hoping to find this distance from. Oh, I need to find this angle. Sorry, and I need to find that angle there. But we're also told that it's 5 kilometres, so this is a length of 5, and that's a length of 5. All measurements in kilometres. Now we can go ahead and find those angles pretty easily, can't we? We're going to use our sine rule, so we'll go and do our working over here this time. Now we're looking for the angle I'm going to call angle P theta, very creatively. So sine of theta divided by the opposite angle, which is 9, would be exactly the same as the sine of the 20-degree angle that we were given to start off with, and divided by that length of 5. So sine theta equals 9 sine 20 divided by 5. Theta equals the arc sine of that. 9 sine 20 over 5. You don't want to calculate that first and have to round off. Try and do it all at once. And we are going to get our answer right here. Let's go ahead and do that now. Now, when I go into run mode, it's very tempting just to jump in, but we are doing trigonometry here. Earlier on in one of the papers, I'm pretty sure I was using radians along the line there somewhere. I would always encourage you, whenever you're going to do any of these, to check your setup. And just make sure you're in the right mode. You can see here I'm in radians. We don't want to be in radians, we want to be in degrees mode. So let's go ahead, put ourselves in degrees mode. Now it's going to work. So shift the arc sine of 9 sine 20. And I'm going to need to go back and put in another little bracket here, aren't I? Whoop, too far. So 9 sine 20 being divided by 5. Close the bracket so it'll work out all of that first, and then do the arc sine of that. 37.9982. 37.9982. You can see I was getting carried away with the IB. Oh, that's not the eraser. I've got to turn it upside down. Okay. Remember the new practice. We are better off writing it to 6 decimal places first. So theta equals, or is approximately equal to 37.9982. We can round that off to 38.0 degrees. I need the 0.0 because I need to have it to the correct number of decimal places. Over here, Q is going to be alpha. Therefore, alpha equals 180 minus theta. Alpha is going to equal, remember this is the other value from the arc sine. You can also get that from Your best friend in maths, the unit circle. Here we had one angle of 38 degrees. The other angle that corresponds to the same sign is 180 minus 38, or 180 minus that. Again, you should probably do the full workings. This is 180 degrees minus 37.9982. What's that going to be? 142.0018. And then you can show that you've rounded it off. So alpha is 142 degrees. Now, they didn't give us alpha and theta in the question, so let's write them the way they want them. Angle SPL is equal to 38.0 degrees. And angle SQL is equal to 142 degrees. Excellent. Part C. Let's see if I can just give us a bit more room here. Part C. First part of Part C, CI. State which of the points P or Q is chosen for the new supply store. How do we know? The town wants the new supply store to be as near as possible to the town. Town is here. Which point is going to be chosen? Q is obviously nearer than P. So, it's really just a matter of reading. Point Q is chosen. I would have said selected. Chosen's a pretty average word, but they've gone with it. Let's do it. And the last thing we've got to come up with, there I am. Last thing we've got to come up with, C part 2. Hence find the distance between the old supply store and the new one. Well, now we can go ahead and figure out what this distance here is, and then from that we can figure out the total distance there, or of course we've just got to find, oh no, that's all we need, from the supply store to the new one. That's all we want there. We've got two sides. We know these two angles, so we can find the other angle. I think I'd be going ahead with that. So if I wanted to do it using the sine rule, and you could use the sine rule or the cosine rule for this, so angle QLS equals 180 degrees minus the 142 degrees and minus the original 20 degrees. So that's 18 degrees. Therefore, QS over the sine of 18 would be the same as 5 divided by sine 20. So QS equals 5 sine 18, just multiplying each side by sine 18 there. 5 sine 18 divided by sine of 20. And we've got the distance QS. Go to our calculator and find the answer. Hopefully my ugly mug's not covering up that working. I'm just going to scroll it up anyway in case it is. 5 sine 18 divided by sine of 20. 4.5175. 4.5175. I know that's not to the recommended 6, but that's close enough. Therefore, QS approximately equal to 4.52 kilometres. All done. There you go. That's a nice 13 marks. All right, only a couple of questions to go. Nearly there. All right, catch you in the next one.